Now let's see various methods by which we can implement a symbol table. I'm showing you all the various data structures available, and then if you implement it, the symbol table using these data structures, I'm telling you how much time is required for the insertion time, lookup time, and what are the disadvantages of it. Okay, now let's see this one first. If you are going to implement a symbol table using a linear list, so linear list means either it can be an array or a linked list, right? So let's see what happens with the times here. If you are going to implement it using an array, first thing is it is difficult for us to implement it using an array because we don't know the exact size of the symbol table. Therefore, practically we don't go with arrays, but just for the theory sake, we have written it here. Now in case if you are going to implement it using an array, and if that array is sorted, then if you have to insert an element, you might have to move all the elements to the right. So that is why, just like insertion sort, inserting an element into a sorted list or sorted array is going to take order of n time. And coming to the lookup time is nothing but the search time. If array is sorted, then in order to search for an element, you can use the binary search, and the binary search is going to take order of log n. Now if you implement the same thing using a linked list, right, in order to search for the position at which this particular element has to be inserted, time taken will be order of n, right? And after searching for its position, then only you are going to insert it. That is why time taken will be order of n. You have to search the entire list. And now if you are looking at the time taken to search for an element, again it is also going to be order of n, because you cannot apply binary search on a linked list, right? Why? Even if you try to apply binary search on a linked list, it is going to take a lot of time. It is better you don't go with that. It is going to take order of n time, right, if you go with linear search. Therefore, on a linked list, you are going to use linear search in order to insert an element as well as search for an element, right? But here, in order to insert an element, you can find out the element's location in order of log n time in the array, and after you find out the location, you might have to shift the elements. That is why it is order of n time, right? And for searching an element, it is order of log n. And coming to the unordered list, again in unordered list also you have two variations. One is array and the other one is linked list. In both the cases, if you are going to insert an array, insert an element, it is going to be order of 1 time, right? Why? If you are going to insert an array into an unsorted list, in case of an array you can directly insert it at the end, and in case of a linked list you can insert it at the beginning, isn't it? Therefore the time taken is order of 1. See, I think you know how to insert an element at the beginning of the list in order of 1 time. If you don't have any restrictions like sorting, now let us say this is the list and this is the head, right? Now how you can insert a newly formed one node into this is, you can create a new node and you can make that node point to the head 1, and you can make this head point to this, right? Therefore in order of 1 you can insert an element into a linked list if it is unsorted, right? And if it is unsorted array, you can place the element at the end. Again it is also going to be order of 1 time. So it is order of 1 time. And what about the lookup time? Lookup time is the time taken to search for an element. If you are going to search for an element, right, so the time taken to search for an element here is going to be order of n, both in case of array as well as the linked list. So why is this so? Is you will have to search the entire list. In both the cases it is unsorted, that is why. Now one thing you should be careful about is, whatever method you are using, always you are going to search for an element before you insert it, right? And so insertion time might be affected. See, whatever insertion time I am telling you here is based on the assumption that there are no duplicate elements. Sometimes what happens is, if an element is declared 2 times, then before inserting an element into the symbol table, you should also check whether that element is already present in the list or not. In that case, every insertion will also need a search for the element, right? So I am not taking that into consideration. I am just assuming that we are not going to have duplicate elements. In case if we have duplicate elements, you will have to search before you insert, right? So removing this, I am telling you all the times. Just keep that in mind. Now in the exam, if they specify that no duplicate elements are allowed, then you are supposed to search before you insert, okay? And the next one is self-organizing list. So what is a self-organizing list is, it is a normal linked list only, But what we do is, whenever we search for an element, when we find it in the list, we just move it to the beginning of the list, so that most recently accessed element will always be close to the head. Head means the beginning of the list. Now what happens because of this one is, the frequently accessed data will be present at the beginning of the list, and so you will be able to find such elements with very less time. You need not search the entire list, it will be present at the beginning, right? So that is about self-organizing list. Now since a self-organizing list is generally an unsorted list, if you have to insert an element, the time taken will be order of 1, because you will be inserting it at the beginning, right? And what about the time taken to search? Since it is an unsorted list, you will have to search the entire list in the worst case, and so time taken will be order of n. But only thing is, after you search and find an element, you get that element and put it at the beginning, so that next time when you search for it, you will be able to find it easily, right? Okay. And the next one is search tree. So you can also implement it using search tree. So there are various types of search trees, like binary search trees, B trees, B plus trees, all these trees are possible. Now coming to the search tree, if it is balanced, then it will give us the best performance. If you have n elements in the tree, and if the order of the tree is k, then the height of the tree will be in the order of log n base k, where k is the order of the tree. In case of binary tree, it is going to be log n base 2. In case of ternary tree, it is going to be log n base 3. In case of binary search tree, right? Okay. So in the binary search tree, it is going to be 2. Now, if you are going to use a search tree in order to implement a symbol table, then the time taken to insert an element will be equal to the height of it, will be proportional to the height of it, and so it is going to be done in order of log n base k time. And if you are searching for an element, again it is also going to be log n base k time. And the next one is hash table. So hash tables are generally used in order to in order to have the constant time. So both for insertion and both for lookup searching, it is going to be order of 1 time, and in some cases, if your implementation is not very good, then sometimes what happens is there will be collisions, and again you will have to resolve the collisions using chaining and open hashing, all these techniques, and then the time complexity might increase. But if you look at it, on average the time taken should be order of 1. Now let's see the disadvantages of each method here. Now the disadvantage of the linear search is, if you are going to have if you look at the search time in the linear list, the search time is proportional to the size of the list in case if it is unordered list. In case of ordered list, you can do it in a log n time in case if it is an array. In case of a linked list, either it is ordered or unordered, you might have to search the entire list, and therefore the lookup time is directly proportional to the size of the table. And every insertion operation is preceded by a lookup operation. So if you are going to insert into a sorted list, right, then you have to search for the location where the element has to be placed. So that is why you might have to do a search operation before you insert it. So that is a disadvantage. And coming to the self-organizing list, so whenever you are going to search for elements which are less frequently used, then the search time is going to be worst. In case if you keep on searching an element frequently, then that element will appear at the beginning of the list, and it is going to give you better time. Now if you are not going to always search for the frequent elements, if you are going to search elements randomly, then it is not going to give you better performance. Alright, therefore it is useful only when some elements are searched with higher frequency compared to the other elements. Okay, and next one is search trees, and in the search trees we have to always keep it balanced. If you are not going to keep it balanced, then there is a problem called as skewed trees. If the tree is going to grow only in one side, then the problem is the height of the tree will be proportional to the number of elements, which is nothing but n. Then instead of order of log n, we might get order of n. Therefore you have to always keep it balanced. And coming to this hash table, the disadvantage is, if there are too many collisions, then the chain, we have discussed this thing in data structures in hash tables. So I told you that if there are too many collisions, then the time complexity is going to increase, and it is going to increase to order of n if the length of the chain is too long. So what is a chain and why are we using it? That everything will be discussed in the hash table topic. you can refer to it in data structures. Okay, so these are various implementations we have, and these are the various times they have, and these are the disadvantages. Okay, fine.